Salam sejahtera dan good morning, Doctor. This is the video presentation of report Mechanics of Material from Group 6, Section 5. Our title is Water Tank Design. Our group members are Lian Chunyi, Ho Chen Pui, Chen Kelly, Siti Khadijah binti Awang, dan Rabiatu Adwiya binti Nasri. Next part will continue by my members.
Okay, Assalamualaikum warahmatullahi wabarakatuh. My name is Khadijah binti Awang, CF 2076. Okay, I will introduce about the water tank design. The meaning of water tank design is to provide the safety of water storage from the number ambient negative influence, such as bacteria, virus, algae, change in pH water, mineral, and also accumulated gas. Okay, accurately designed water tank work to address and mitigate this negative effect, and also it is desirable that water tanks be cleaned annually to reduce the delivery of algae, bacteria, and virus to people or animals. There are three types of water tank design, such as first one is chemical contact tank. Okay, the chemical contact tank allows for retention time for chemical to contact chemical treat with a product water. Second, groundwater tank, made from steel and it may receive from water well or surface to allow large volume of water during peak demand cycle. Third one is elevator water tank, and also as water tower or vertical cylinder hold from 200 liter to several million of liter. Okay, the main factor to consider such as material, tensile, environment, corrosion, resistant coating, and safety factor. The right design is required to ensure the water can continue to supply us safe and enough water for humankind. Thank you.
Good morning, Doctor. My name is Lian Chunyi, and I would like to present the background study of the report. Water tank specification include the tank's overall design, application materials, and line lengths. Various materials are used for making a water tank, for example, plastic and concrete. The pressure of water tanks determine the effectiveness of pipe water supply. According to Pentoscope 1998, concrete water reservoir of 2 to 15 megaliters are commonly used as heater tanks to hold water pumped from a far source in a small town. The water is then stored and given to a specific neighborhood at a steady rate. To store and distribute safe for drinking water, reinforced concrete overhead water tanks are used. Water tank. In general, there are three types of water tank: those that sit on the ground, underground, and elevated. Table 1 shows how water tanks are categorized depending on their location and shape. Tanks can be circular or rectangular in shape. On the ground or underground may have a flat bottom, whereas those that are elevated may have a conical or flat bottom. That's all from me. Thank you.
Hi everyone, my name is Chen Kelly. Now I'm going to present about the circular water tanks. These are the details of the circular water tank that we want to design. Capacity of 400,000 liters, flexible connection at base, freeboard of 200 millimeters. Height of the tank is 3.5 meter and open at top. Concrete M30 and 420 megapascal steel is used in the design. First, we need to find the dimension of tank. We can find the depth of tank by using the formula 3.5 meter minus with 0.2 meter equals to 3.3 meter. Then we find the volume of tank by divide the capacity with 1000, which is equals to 400 meter cubed. Insert all the data that we get just now into the next equation. We found that the diameter of the tank is about 12.5 meter. Second, the modular ratio of M30 grade of concrete. Given that the presentable bending stress of the concrete is 7 megapascal, we insert the data into the formula. We found that the modular ratio is 30.33. Thirdly, the maximum hold tension. By insert all the data that we get just now into this equation, we found that the maximum hold tension is equals to 240.5 kN. Next, area of reinforcement AST. AST can be found by dividing the maximum tension hold with the presentable stress of steel, and it gives us a result of 1650 mm². Next, we can find the spacing required for the reinforcement and insert all the data into the formula. We found out that the answer is 121.87 mm² center to center. And in this area, we will use the bar with diameter 16 and apply it with 100 mm center to center as hook tension steel. Meanwhile, at height of 1.65 meter, the tension is half of the tension at base, and we can find the AST by using the maximum tension hook divided by the presentable stress of steel, and it gives us a result of 825 mm². Next, we find the spacing required for the reinforcement, which is 243.74 mm center to center. In this area, we will use bars with 16 diameter and apply it with 200 220mm center to center as the hook tension steel. Next, we need to check for the tensile stress. The area of steel provided AST provided can be found by using the data and insert into the formula, which gives us a result of 2011 mm². And the AST minimum required for this project is 0.3% of the concrete, and we found that the AST minimum is equal to 225 mm². Since the area of steel provided is higher than the area of steel minimum required, hence this design can be accepted. Next, the thickness of the wall of tank. The presumable stress of the concrete must higher than the T over 1000 times T plus modular ratio minus 1 times with area of steel. Hence, we found that the thickness of the wall is higher than 140. So in this design, we will use the wall of tank, which is 150 mm. The distribution reinforcement. The distribution reinforcement for this project is provided at 0.3%. We can calculate the AST provided, which is equal to 452.45 mm². And we found out that the AST minimum is lower than the AST provided. So in this design, we can use bar with 12 diameter as the distribution reinforcement and apply it with 250 mm center to center. Last but not least, the tank floor. The minimum of thickness 150 mm and 0.3% of steel is needed for the tank floor. We found that the AST minimum is equal to 225 mm². Meanwhile, the spacing required for the tank floor is 223.43 mm center to center. Hence, in this design, we can use the bar with 8 diameter in the direction of top and bottom of the tank floor and apply it in 200 mm center to center. That's all from me, and this presentation will be continued by my friend. Thank you.
Now I will present about the RC rectangular water tank. CIMIC method, the simplest method for water tank analysis. Assumption in this method, bottom 1/4 or 1 meter is predominantly under cantilever action. The rest of the wall is resisting the water pressure by forces developed in the horizontal direction. Cantilever effect is depend on the size of the tank and the thickness of the wall. Design of rectangular tank by using approximate method is classified into two categories. First is ratio length over breadth less than 2 and ratio length over breadth more than 2. Ratio LOB is less than 2, slab with horizontally around the tank. Triangle load due to hydrostatic pressure act on the wall from the top to h/4 or 1 meter above the base. Wall from the bottom junction up to height h is treated as a vertical cantilever fixed at the base. Ratio LOB more than 2, the short wall are regarded as horizontal slab bending horizontally between long wall. Long wall are treated as vertical cantilever fixed at the base. Important parameter in water tank design. First, grade concrete greater than M20 is used. Minimum height of wall is 3 meter and thickness is 300 mm. Longer side of the tank should not be more than twice of the smaller side, and maximum bar spacing is 300 mm. The minimum reinforcement shall have an area of 0.3% of the concrete section in that direction for section up to 100 mm thickness. For section of thickness greater than 100 mm and less than 450 mm, the minimum reinforcement in each of the two directions shall be linearly reduced from 0.3% to 0.2% concrete section. For section of thickness greater than 450 mm, minimum reinforcement in each of two directions shall be kept at 0.2%. The minimum cover shall be a 25 mm diameter bar, and the design code used for water tank design is IS 3370. Rectangular RC water tank designed by using approximate method. Commonly has 6 steps in calculation. Design a 5 meter width times 6 meter length rectangular water tank with 4.8 meter height. Assumption parameter is given as below. The concrete we use is M25. Reinforcement is FE415. 2. Permissible stress. Based on IS code, permissible stress in bending compression for concrete M25 is 8.5 Newton per millimeter squared, and the permissible stress in steel is 130 Newton per millimeter squared. The design constant JKQ can be found by using formula. The modular ratio M is 11, K is 0.48, J is 0.86, and Q is 1.52. 3. Dimension of the tank. The length of tank is 6 meter and its width is 5 meter. Thickness of wall is 194 mm and 360 mm. Since the ratio L over B is 1.2, that is less than 2, design wall spanning horizontally. The H is 1.2 meter and the water pressure is 35.31 kN per meter. Step 4. Design of long wall and short wall. For long wall, effective span for short wall is 5.36 meter and effective span for long wall is 6.36 meter. Bending moment is 119.02 kN meter and tensile force is 88.275 kN. provide 25 mm diameter bar and cover 25 mm. The effective cover is 37.5 mm and effective depth is 322.5 mm. We sub in the reinforcement area formula, we get 3631.16 mm square and the spacing is 130 mm. Next, we will repeat the step with bending moment at center. The bending moment at center is 89.26 kN per meter. The reinforcement area is 3154 mm square and the spacing is 150 mm center to center. Next, we analyze the short wall. We repeat same step as long wall. The result for reinforcement area is 2740.62 mm square. The reinforcement at the corner is 25 mm diameter steel bar at 160 mm center to center. Reinforcement in the center of wall, the area is 2154.57 mm square. The reinforcement is 25 mm diameter steel bar at 220 mm center to center. Step 5. Design for cantilever action. Maximum pressure at bottom of wall is 47.088 kN per meter square and maximum cantilever moment is 11.29 kN meter. Using 12 mm diameter bar, the effective cover is 56 mm and effective depth is 304 mm. The minimum reinforcement area is 1080 mm square and the spacing is 100 mm. Last is base step. Assuming thickness is 200 mm, the reinforcement area is 600 mm square. Using 10 mm diameter bar, the spacing is 130 mm center to center. That's all for rectangular tank design. Thank you.
Assalamualaikum and hi, I'm Rabiatul Arabia binti Nisri and my magic number CF2070. I would like to continue the presentation with the last part, which is recommendation. Okay, let's start. In order to avoid leak and grade of grade F20, liquid returning is recommended. It is because permeability of concrete is directly proportional to water cement ratio. Proper compaction using vibrators should be done to achieve imperviousness. The water tank parameters includes the general design of the tanks. Construction material that we use for making water tank should be designed properly to prevent from bacteria, change in pH, and accumulated and can keep the quality of water. Besides, the choice of lining to be applied and shape of tanks must be considered too. Furthermore, material selection also should be considered to apply the water storage tank such that the contents are not subject to insanitary pollution. It should be located at easy enable access in terms of human convenience for inspection, maintenance, and repair. Besides, the calculation and measure before doing the design should be taken properly to prevent a sudden internal pressure and drop caused by any uncontrolled release of water. Last but not least, the internal radius and height of the tank must maintain constant while the thickness of the wall is varied along the axis so that the bending of tank head and hook stress the tank value as close as possible to their respective allowable values. Only the piecewise linear variations of wall thickness are considered. That's all from us. Thank you very much for watching our video.